Friends, welcome to my channel JM Learning. Today we are going to learn the open circuit and short circuit test on single phase transformer, the experimentation, discussion, and from these two tests we will be going to calculate the various parameters of the transformer. Now let us first discuss the open circuit test, which is popularly called as the OC test on transformer. Now for this particular test, we have to connect the transformer low voltage winding to the supply system, and at the same time the high voltage winding is usually kept open. Now the low voltage winding is to be applied the rated voltage at rated frequency, and the various parameter on the LV side, that is the current, voltage and power, are recorded for calculation purpose. Now from this test we will be able to estimate the iron losses, the transformation ratio, and parameters of magnetizing branch of the equivalent circuit, which we sometimes call as the no load circuit parameter of transformer. Now to perform this particular test in a laboratory will require a transformer of usually rating of single phase type 1 kVA 230 volt oblique 115 volt. Then to get the required supply voltage to be applied to transform during test will require a auto transformer of 230 volt or 270 volt single phase type of 10 ampere. Will require the AC voltmeter of MI type to measure the voltage on LV side. Then to measure the current during this test will require the ammeter of low current rating, that is usually 1 or 2 ampere. Again it will have MI type, and a low power factor meter which have voltage rating of 115 volt and current rating up to 1 ampere. We have to use the low power factor wattmeter for this particular test, as the power factor involved during this test is of lower value, and the LPF type wattmeter gives us the more appropriate readings during the test. Now let us see the circuit diagram for this particular test. On the right side we have to place the transformer, as the HV is to be open, or we can connect it to a voltage voltmeter to measure its voltage, and the LV is to be connected to the supply system here. Now the supply system will be derived from the single phase 230 volt supply, which is our usual supply in India. Then will require the ICTP or MCB to protect the circuit. On the right side will require one auto transformer I discussed previously to apply the correct voltage. The ammeter, voltmeter as required to be connected in circuit as shown in circuit diagram. We will have to connect a low power factor meter, a low power factor type wattmeter we have to connect here. So the wattmeter will have the 4 terminals. For current coil terminal it will be M and L. M is to be connected to the main side, that is to the second terminal ammeter. Then the load side terminal is to be connected to the one of the winding of LV type. Then the common terminal is to be connected to M, which we call as shorting the MNC. The remaining terminal marked as the V, which may be for this case 300 volt mark, so that voltmeter terminal or V terminal we have to connect to the remaining terminal of LV winding, and that terminal will further go to voltmeter terminal, then the auto transformer another terminal. In this way we complete the circuit. Now in this particular test we have to keep the HV open or connect it to a voltmeter of particular range. Then the LV winding which we have connected to the supply side, we have to apply the rated voltage at the rated frequency to this, and note the reading of the voltmeter, ammeter, and wattmeter. Wattmeter reading once we take, we should first check the multiplying factor of the wattmeter, as multiplying factor will be there on the meter itself, or we can also calculate it as multiplying factor is equal to voltage range into current range into power factor divided by the FSD, that is the full scale deflection of this particular wattmeter. So if it is more than 1, then we have to multiply the readings of this wattmeter by that multiplying factor, which may be 2 or 4 in some cases, and that should be our final reading to be written in the observation table, which we'll discuss laterwards. So for this particular test, 3 readings are very much important. The reading at the open circuit condition, that is the no load condition, which will be I0, the voltmeter reading, which may be called as V1 or V0, the wattmeter reading, which we call as W or W0. So these 3 readings, once we take for rated voltage, rated frequency, will be utilized to calculate the various parameter of the transformer. Now after that, we'll discuss on the short circuit test, which is popularly called as the SC test on transformer. For short circuit test, usually the LV winding is to be shorted. So the LV winding which is shorted, then the HV winding is to be connected to a low voltage supply system in such way that we have to circulate the rated current of the transformer in the HV side winding. Thereby at the same time the LV side will also carry the rated current on its side. So this type of the test is utilized to estimate the copper losses in the transformer and also to determine the equivalent circuit parameter of transformer, that is equivalent resistance, equivalent reactance, equivalent impedance. For this particular test, again will require the transformer of single phase 1 kVA 230 volt by 115 volt, an auto transformer to adjust the required voltage, AC voltmeter to read how much voltage we applied during the test, AC ammeter to record that rated current flowing through the HV side, then a wattmeter of the required rating as the voltage to be applied is of low voltage category, so will require a whole wattmeter of 0 to 150 volt, and the current depending upon the capacity of transformer 5 or 10 ampere. In this particular test, if we want to find first the ranges of the various meter, then we have to calculate the current on HV and LV side. If you take example of single phase 1 kVA 230 volt 115 volt transformer, then the HV side current will be approximately of the 4.6 ampere. We can calculate the current from this kVA capacity. We know that the V1 into I1 divided by 1000 is equal to the kVA rating. So by that formula we can be able to calculate the I1 and I2, as the transformation ratio here is of V2 upon V1, that is of 1/2, though current on secondary will be double that of the HV side. So HV side current is if of 4.6 ampere, then we can use the ammeter of 5 ampere range, a voltmeter of 0 to 75 volt, a wattmeter of 0 to 75 or 115 volt voltage rating, then its current coil rating should be 5 ampere, as the current circulating through this HV side circuit will be rated current, and just I told you that rated current will be of 4.6 ampere. Now on the supply side will require, as per our OC test also, the ICDP and the MCB to protect the circuit on the right side. Now this particular test, when we have to perform, we must take care that the auto transformer must be at its 0 position. You ensure first it, then secondly you ensure that the LV winding is properly shorted or connected through ammeter whose range must be greater than the rated current of the LV winding. For this the current will be of 9.8 ampere approximately. So to 10 ampere ammeter will be suitable. Once upon these two conditions are fulfilled, then third is to know the multiplying factor of this wattmeter for the given voltage and current range, which we require to multiply the reading of wattmeter. After that, then on the supply system, then gradually increase this voltage by varying the knob provided on auto transformer. You have to repeat slowly the increase in voltage till this ammeter reaches the rated current of this particular transformer under test. Once the ammeter shows the rated current, we have to stop increase of any voltage further, then take reading of the voltmeter at VSC, then reading of ammeter at ISC, reading of wattmeter as WSC. So these three readings are to be taken. Same time we can observe the current in the LV winding also, which should always be of rated value. As the current in HV side has rated value, then current on LV will also be of rated value. So once these three readings are taken, again decrease the voltage to the 0 value, then switch off the supply system. Never switch when we have circulate rated current, because directly switching off such a inductive circuit, there is possibility of generation of the EMF inside windings, which can be harmful to the transformer itself. So once these two tests and their readings are being noted, you have to write that reading in the observation table. For open circuit test, the voltmeter reading will be calling as V0, the ammeter reading will be calling as I0 in ampere, the no load power will be calling as W0, the secondary voltage will be of V2 in the volt unit. For short circuit test, whatever the voltage required to circulate the shorted current or rated current will be called as VSC. So put its value here. The rated current value should be put in the second column. The wattmeter reading should be put here only after multiplying the required multiplying factor with the readings, and the secondary current I2 as noted by the ammeter put on the LV side, that current will be here. Once these readings are being put up, then we can proceed for the calculation. As earlier I told you that open circuit test we can determine the magnetizing current components or no load circuit components. From that first we can get the value of cos of phi 0 as the ratio of W0 upon V0 I0, which is our no load power factor. We can plot it on this particular phasor diagram here. X-axis shows the flux, y-axis shows the voltage V1 or V0. We can draw that I0 of required scale with the angle of phi 0 here. So this I0 will have two components. One is the magnetizing current component, which will be in phase with the flux. This component is responsible for producing the required magnetic pulse in the core of transformer, thereby which the EMF is induced in both primary and secondary winding or HV and LV winding. So this current will be called as IM. IM will be equal to I0 into sine of phi 0. You can see from this diagram, if we require the value of IM, we have to take the sine of this phi 0. Another component of current, which is known as the loss component of current, IC or IW, and that current will be in phase with the voltage. This component of current is responsible for consumption of power during OC test or no load test. So that current will be equal to I0 into cos of phi 0. Now once we know these IC and IM component of no load current, that is I0, we can further estimate the resistance and reactance of no load circuit, that is R0 is equal to V0 upon IC and X0 equal to V0 upon IM. both of these calculation will be in the ohm. So this way we can get the value of no load circuit parameters, that is R0 and X0, for further plotting of the equivalent circuit of transformer or determining its parameters. In the short circuit test, as earlier we discussed, that we get the equivalent circuit parameter as the HV winding is given the supply and LV is shorted. So HV will be of primary side. So R01, that is the resistance of that particular transformer referred to the HV side, primary side, is equal to the wattmeter reading during short circuit is WSC divided by ISC square. This equation we got from our basic equation, that is W is equal to I square into R. The common equation we use in fundamental of electrical engineering. So R01, whatever value you can calculate here. Then Z01, impedance of transformer referred to primary side, will be equal to ratio of voltage of short circuit to the short circuit current. It will again be in ohm. Once we know the R01 and Z01, we will able to calculate the X01 by putting it under square root of Z01 square minus R01 square, which we got the equation from the impedance triangle. So X01 value will also get here. Now once we get this equivalent circuit parameter and two losses we are getting from the open circuit test, that is the iron loss, and the short circuit test, we are able to calculate the copper loss at full load. Then we can estimate the efficiency of the transformer at any kind of load by use of this equation. Efficiency of the transformer will be equal to X into VA rating into cos of phi. Divide this product again by X into VA rating into cos phi plus W0, which is iron loss from OC test, plus X square WSC. WSC is the copper loss from short circuit test. Now this equation we are using the X as a parameter. So X denotes the percentage of fraction of the full load. If we have to calculate at full load, X will be equal to 1. If we have to estimate the efficiency at half load, then put value of X as 1 ohm, that is 0.5. If you want to calculate efficiency at 3/4 of full load, then X will be equal to 3/4. So same equation we can use to calculate efficiency at different load conditions. Basically we must know the power factor at which we have to calculate efficiency, then we must know the iron losses of the transformer, and we have to get the copper losses at full load from the short circuit test. On the same line, we can able to calculate the voltage regulation of transformer, which is referring to the voltage drop in the transformer equivalent circuit. On what side we have performed the test, we can use either this first equation or second equation. If you have performed on primary side, we can use this equation, which has I1 R01 cos of phi plus or minus I1 X01 sin of phi. This total term is to be divided by rated voltage on primary side. If you multiply by 100, we get percentage regulation. Now the plus sign and minus sign is there. Plus sign is to be used for the lagging power factor. Minus sign is to be used for the leading power factor. If we have performed this short circuit test on secondary side, then this next equation we can use. Replace the primary side component by secondary side component, keeping the cos phi and sin phi as same. The equation become I2 R02 cos of phi plus or minus I2 X02 sin of phi. Divide this whole term by V2 of rated value. Multiply that answer by 100, we get the percentage voltage regulation. So in this way we will be able to calculate the various parameter of the transformer. From the open circuit test we get the iron loss of transformer, then we get the magnetizing current, iron loss component of current, then the R0 and X0. From the short circuit test we determine R01, then Z01. From both of them we get the value of X01. Then we'll be able to get the efficiency and percentage voltage regulation of transformer. So in short, the open circuit test and short circuit test will be helpful to determine various parameter of the equivalent circuit of transformer along with the two losses, iron loss and copper loss, and all these parameter will be helpful to calculate the two most important performance criteria of transformer, that is the percentage efficiency and percentage voltage regulation. I am sure that you got the understanding of these two tests. Thanks for watching this video. Do like and share it, and also subscribe my channel JM Learning.